Okay, so this is section 4.3. Hopefully you did the homework from 4.2, completed the practice quizzes, checked your solutions up online. That's all there for you, so please make sure you're doing those things. It's tough for me to check up on you. Like always, if you have questions when I'm away, please feel free to email me, mrvalconi@gmail.com. If you need me. I will do my best to answer you. However, I'm not sure how internet will be out there. But like I said, whenever I can, I will be sure to check in with you. So today we're looking at chemical properties and the difference between physical changes and chemical changes. So this is a little bit of a bigger lesson. So sit tight and get ready. So in terms of chemical properties, there are four really big ones here. So the first one is reactivity with water. So I'm going to ask you to just copy down this example. You'll notice that all of the chemical properties have one thing in common, and that thing in common is reactivity. So in order to determine a chemical property, we need to mix it with something to see how it reacts, and that's really what chemical properties are all about. So for this example, calcium carbide is just a compound, and it reacts with water to produce this type of gas. And I have a video here, and it shows how not how dangerous water can be, but how dangerous other elements can be when they react, because some elements do have a very, very, very high reactivity. So we're going to take a look at some of that, and I think we started talking about that as well. But some elements are very, very unstable. So let's take a look at this one. So just an example of how reactive things can be when placed under the right circumstances. Oxygen. So aluminum metal reacting with oxygen is a classic example. You might know this as aluminum oxide, or more commonly as rust. So if we leave a metal outside in oxygen for a long time, eventually we get rust, which is just a buildup of a different chemical on top of that metal. These YouTube videos, I'm going to ask the teacher, if possible, to just go through the lesson after I'm done. Any of the students can pull it up on LMS, and you can just watch the YouTube videos as a class, just because it's really difficult for me to narrate the audio as it's happening. Reactivity with acids. Lots of things react with acids. It's generally a really nice property about acids. A really good example is baking soda and vinegar. Vinegar is an acid, baking soda is a base, and these two things kind of react when they meet each other, which is where you get like your awesome volcano experiments from. So if you've ever made a volcano, you've probably mixed vinegar and baking soda, and it causes everything to kind of shoot up. That's because there's high reactivity with acids. Combustibility. This is all about how easily something burns. So a match would have very high combustibility. Propane would have very high combustibility as well, which is probably how some of you start your barbecues at home. So combustibility is all about how easy, or the ability of a substance to burn in air. So like always, if the teacher could just pause while the video is going, to give the students an opportunity to copy the slides as they progress. Okay, we are going to skip the section that involves physical and chemical changes. I will be teaching that when I come back on Monday. So what we're going to do now is, if you can just flip ahead to the chemical tests for gases, your quiz. You'll be having a quiz on some of this material, so except for the physical and chemical changes, you pretty much know everything there is to know about Chapter 4, which is great, which means you can start putting together your review. So I have posted the outline for the quiz on the LMS for you, so please make sure you take a look at that and start getting yourself prepared. So let's take a look at some of the chemical tests for gases. So we have three big gas tests that we're going to be using in this course, and we'll see if we get a chance to actually demonstrate these live when I get back. So there's three chemicals that we take a look at analyzing. So first is oxygen, hydrogen, and then carbon dioxide. And we have a different test for each gas. So just later on, this is posted on the LMS, so if the teacher could just go through and just play the YouTube videos for the class, that'd be excellent. The first test is a test for oxygen, and oxygen, like we talked about, is fire's best friend of all time. Those two things need each other, and oxygen is really good at getting a fire going. So the oxygen gas test is if you take like a stick that's on fire and you blow it out, that stick's going to be lit up a little bit, but it's certainly not going to be on fire. But what happens is if you take that stick that's still glowing and you stick it in a container that's full of oxygen, it's going to actually burst into flames. And that's kind of what's going on over here. So we have this stick that's glowing. As soon as you send it into oxygen, that oxygen helps that fire ignite, and you end up with an actual splint that's on fire, which is excellent. And it kind of shows how powerful oxygen is and why it's sometimes a little bit dangerous in terms of chemicals, especially if we're looking at, if you remember back from your GHS symbols, things that react with oxygen. So just keep that in mind. Oxygen gas test relights a glowing splint. So that's the big thing we want to take from that. Number two, hydrogen. Hydrogen is extremely reactive, and when you send fire and hydrogen together, you get an explosion. If I were to do this in class, you would actually be able to witness this explosion. And maybe witness is the wrong word. You might be able to hear this explosion. Because what actually ends up happening is you get a popping sound. So it's a small explosion. It's not going to blow up the school or do anything like that, but you do hear a pop. And that's because hydrogen is very reactive. So if we send a splint that is on fire into a container filled with hydrogen, you will get a pop. So if you get the pop, that's hydrogen. So please make sure you have that. And the last one is carbon dioxide. So we find this a lot of times in our fire extinguishers. Carbon dioxide is fantastic at putting out fires. So if you have a burning splint, so a splint that's on fire, you send it into a tube filled with carbon dioxide, that fire is going to go out, kind of like putting it into a fire extinguisher. They work in the exact same way. So the last gas test is carbon dioxide, and it will send a fire out. So pretty much instantly eliminated. All right, those are the three gas tests. Please make sure you get those notes, and you can start reviewing for your quiz. Your quiz will be next week. I will talk more about that on Monday when I get back, and we cover section 4.3 physical and chemical changes with you. All right, please make sure you're also doing those quizzes on the LMS. I am checking to see how you are doing. All right, thank you very much. We'll see you and have a good weekend.